The thermal property of matter. Heat and temperature. Heat is a form of energy transferred between two systems or a system and its surrounding due to temperature difference. Temperature is a measure of hotness of a body. The SI unit of a heat energy is joule. The SI unit the SI unit of temperature is Kelvin and degree Celsius is a commonly used unit of temperature. Conventionally, the heat energy Q supplied to a body is taken to be positive and the heat energy given out of a body is taken to be negative. Measurement of temperature. A measure of temperature is obtained using thermometer. The commonly used property is variation of the volume of a liquid with temperature. Commonly used thermometer scales are Celsius, Kelvin and Fahrenheit scale. Now we have learned about the relation between different temperature scale. At standard pressure, freezing point of water is 0 degree Celsius, 320 Fahrenheit, 273.15 Kelvin. Lower fixed point. Okay, the boiling point of a water 100 degree Celsius is 2 212 Fahrenheit and 373.15 Kelvin. Upper fixed point. Okay, upper fixed point. In Celsius and a Kelvin scale, the temperature difference between freezing and boiling point of water are the same. 0 Kelvin is called absolute zero because this value we cannot find any temperature in the universe. Conversion of temperature from one scale to another. Celsius to Kelvin. Celsius to Kelvin. Okay, where C plus Kelvin is equal to C plus 273.15. Changing conversion of temperature from one scale to another. Now, Kelvin to Celsius. Kelvin to Celsius means the temperature Kelvin minus 273.15. Celsius to Fahrenheit. F is equal to F is equal to 1.8 into C plus 32 means if minus 32 is into mm, C by C by 5 C by 5 is equal to F minus but M F minus 32 beta में 9. Okay, F is Fahrenheit in F is temperature in Fahrenheit, Fahrenheit to Celsius, Fahrenheit to Kelvin. Okay, Kelvin to Fahrenheit. Kelvin is equal to Fahrenheit minus 32 plus 273.15 Kelvin. Graph over temperature in Celsius versus temperature in Fahrenheit. Okay. Boyle's law. When temperature is held constant, the pressure and the volume of a quantity of gas are related as PV is equal to constant. Charles law. When the pressure is held constant, the volume of a quantity of the gas is related to the temperature as V by T is equal to constant ideal gas equation. PV by T is equal to mu into R. PV is equal to mu into R into T, where R is equal to 8.31 joule per mole per Kelvin, where mu is the number of mole in the sample of gas and R is called universal gas constant. Pressure versus temperature of a low density gas kept at a constant volume. With a constant volume, gas thermometer temperature is read in terms of pressure. The absolute minimum temperature for an ideal gas is minus 273.15 degrees Celsius and is designated as absolute zero. Absolute zero is the foundation of a Kelvin temperature scale or absolute scale temperature. Now we have learned about thermal expansion. The increase in the dimension of a body due to the increase in its temperature is called thermal expansion. The expansion in length is called linear expansion. The expansion in area is called areal expansion. The expansion in volume is called volume expansion. The fractional change in dimensional dimension ratio of change in dimension to original dimension is proportional to change in temperature. The corresponding proportionality constant is called coefficient of a thermal expansion or thermal expansivity. Now, types of thermal expansion, linear, area and volume. The dimension that change length, area and volume. Coefficient of uh, alpha L delta L divided by L into delta T. अल्फा ए मीन्स एरियल है ये, तो अल्फा एरियल इज इक्वल टू डेल्टा ए डिवाइडेड बाई ए इंटू डेल्टा टी. अल्फा वी मीन्स द कोफिशिएंट वॉल्यूम एक्सपेंशन, तो डेल्टा वी इज डिवाइडेड बाई वी इंटू डेल्टा टी. थर्मल एक्सपेंशन अल्फा लीनियर एक्सपेंसिविटी और कोफिशिएंट ऑफ लीनियर एक्सपेंशन, एरिया एक्सपेंसिविटी और कोफिशिएंट ऑफ एरिया एक्सपेंशन, वॉल्यूम एक्सपेंसिविटी और कोफिशिएंट ऑफ वॉल्यूम एक्सपेंशन. Relation is equal to alpha A is equal to 2AL, alpha B is equal to 3AL. Shows the coefficient of volume expansion for ideal gas is reciprocal of temperature. Proof: ideal gas equation is equal to PV is equal to mu into RT at constant pressure. First equation, P into delta V is equal to mu R into delta T. Dividing the equation we get delta V is divided by V, original V. The change in temperature is delta T divided by the original T. So we have to delta V is divided by V into delta T is equal to 1 by T is equal to coefficient of expansion in volume is alpha V. Obtained the following relation. First is alpha A is equal to 2 into linear expansion and alpha V means the volume expansion is equal to 3 alpha L. Consider a cube of length L. Due to the increase in temperature delta T, length of a cube increases by delta L in all directions. The coefficient of linear expansion is alpha L is equal to delta L divided by L into delta T. Now, increase in area of a cube is delta A. Final area minus initial area is equal to 2 into L into delta L. Area expansivity is equal to expansivity is equal to delta A bata में A into delta T. 2L into delta L divided by L square into delta T. Therefore, alpha A means aerial expansion is equal to 2 into AL. Due to delta T, the increase in volume of a cube delta V L plus delta L to the power 3 minus L to the power 3 is equal to 3L square into delta L. Neglecting delta L square and delta L cube. Alpha V is equal to delta V divided by V into delta V and 3L square into delta L divided by L cubed into delta T is equal to 3 into A alpha L. Therefore, alpha V means the expansion in volume is equal to 3 A alpha L. Okay. Anomalous behavior of water. Water exhibits an anomalous behavior. It contracts on heating between 0 degrees Celsius and 4 degrees Celsius. The volume of a given amount of water decreases as it cooled from room temperature until its temperature reaches 4 degrees Celsius. Thus, water has a maximum density at 4 degrees Celsius. Environmental effect of anomalous behavior of water. Bodies of water such as lake and ponds freeze at the top first. As a lake cools toward 4 degrees Celsius, water near the surface becomes denser and sinks. The water near the bottom rises. Once the colder water on a top reaches temperature below 4 degrees Celsius, it becomes less dense and remains at the surface and freezes. If water did not have this property, lakes and ponds would freeze from the bottom up, which would destroy much of their animal and plant life. Heat capacity. Heat capacity of a substance is the quantity of heat required to raise the temperature of the substance through 1 Kelvin. S is equal to delta Q divided by delta T, where delta Q is the amount of heat supplied to the substance to change its temperature from T to T plus delta T. A specific heat capacity. A specific heat of a substance is the quantity of heat required to raise the temperature of unit mass of the substance through 1 Kelvin. S is equal to 1 by m into delta Q atom delta T. It depends on the nature of the substance and its temperature. The SI unit of a specific heat capacity is joule per kg per Kelvin. Molar specific heat capacity. It is the amount of heat required to raise the temperature of 1 mole of a substance through 1 degree Celsius or 1 Kelvin. C is equal to S by mu is equal to 1 by mu into delta Q beta में delta T. The SI unit of molar specific heat capacity is joule per mole per Kelvin. Molar specific heat at a constant volume Cv. Molar specific heat of a given a gas at a constant volume is the amount of heat required to raise the temperature of 1 mole of the gas through 1 Kelvin when its volume is kept constant. Molar specific heat at constant pressure. Molar specific heat of the substance at a constant pressure is defined as the amount of heat required to raise the temperature of 1 mole of the gas through 1 Kelvin when its pressure is kept constant. Calorimetry. Calorimetry means measurement of heat. When a body at a higher temperature, when a body at a higher temperature is brought in contact with another body at lower temperature, the heat lost by the hot body is equal to the heat gained by the colder body. Provided no heat is allowed to escape to the surrounding, the device in which heat measurement can be made is called as a calorimetry meter. It consists of a metallic vessel and a stirrer of the same material like copper or aluminium. Change of state. A transition from one state to another state is called change of state. Change of state: solid to liquid, liquid to gas, liquid to solid, solid to gas without forming liquid. Means solid to liquid melting, liquid to gas vaporization, liquid to solid fusion, solid to gas sublimation. During change of state, the two different states coexist in a thermal equilibrium. Temperature, time graph of ice increases and constant then increases. Melting point, the temperature at which solid and a liquid coexist in a thermal equilibrium with each other is called melting point. The melting point decreases with increase in pressure. Boiling point, the temperature at which liquid and vapor state of substance coexist in thermal equilibrium with each other is called boiling point. The boiling point increase with increase in pressure and it decrease with decrease in pressure. Resolution. When a metal wire loaded at both ends is kept over an ice block, it passes through the ice block to the other side without splitting it. The melting point of ice just below the wire decreases due to increase in pressure. As ice melts, wire passes and refreezes due to decrease in pressure. This process is called regelation. Cooking is difficult at high altitude. Why? At high altitude, pressure is low. Boiling point decreases with decrease in pressure. Boiling point decreases with decrease in pressure. At high altitude, pressure is low. Boiling point decreases with decrease in pressure. Okay. For cooking rice, pressure cooker is preferred. Why? For cooking rice, pressure cooker is preferred. Why? In pressure cooker, boiling point of water is increased by increasing pressure. Thus, rice can be cooked at a high temperature. You might have observed the bubbles of steam coming from bottom of the vessel when water is heated. These bubbles disappear as it reaches top of the liquid just before boiling and they reach the surface at the time of boiling. Explain the reason. Just before boiling, the bottom of a liquid will be warm and at the top liquid will be cool. So the bubbles of steam formed at the bottom rise to cooler water and condense. Hence they disappear. At the time of boiling, temperature of entire mass of water will be 100 and thousands degrees Celsius. Now the bubbles reaches no, this is not thousands, this is 100 degrees Celsius. Now the bubbles reaches top and the escape latent heat. The amount of heat per unit mass transferred during change the state of a substance is called latent heat of substance. For the process, if mass m of a substance undergoes a change from one state to the other, then the quantity of heat required is given by Q is equal to ml, L is equal to Q by m. Latent heat is a characteristics of substance and it depends on pressure. Its unit is joule per kg. The latent heat for a solid liquid state change is called the latent heat of fusion, and that for a liquid gas state change is called the latent heat of vaporization. Burns from streams are usually more serious than boiling water. N for water is 22.6 into 105 is heat is required, so the steam carrier. Okay, this is the question. Heat transfer. There are three methods where there the heat is transferred: conduction, convection, and the radiation. Now we have understand about the conduction. Conduction is the mechanism of transfer of heat between two adjacent parts of a body because of their temperature difference. Because of their temperature difference, the rate of flow of heat or heat current H is proportional to the temperature difference Tc minus Td and the area of cross section A and is inversely proportional to the length L. H is equal to Ka into Tc minus Td divided by L. The constant of proportionality K is called the thermal conductivity of the material. The greater the value of K for material, the more rapidly will it conduct heat. The SI unit of Kelvin is joule per second per meter per Kelvin or Weber per meter per Kelvin. Okay. Some cooking pots have cooker coating on its bottom. Why? Because of a high thermal conductivity of copper, it distributes heat over the bottom of the pot very fastly and promotes uniform cooking. Convection. Convection is a mode of a heat transfer by actual motion of a matter. It is possible only in fluids. Convection can be natural or forced. In natural convection, when the fluid is heated, it expands and becomes less dense. It then rises up and cooler part replaces. This process goes on as a cycle. In force convection, material is forced to move by pump or by other physical means. Some examples are cooling system of automobile engines, hots that circulate blood throughout our body. Sea breeze, wind from sea to land on daytime. During the day, the ground heats up more quickly than large body of water. The air in contact with the warm ground is heated by conduction and expands, becoming less dense than the surrounding cooler air. As a result, the warm air rises and the other air moves to fill the space, creating a sea breeze near a large body of water. N is divided by N is eta is equal to W by Q1 land breeze. Wind from land to sea on a night. At night, the ground loses its heat more quickly and the water surface is warmed than the land. Then the land thus a land breeze is set up. Night, air current, land breeze. Radiation. In radiation, energy is transferred in the form of electromagnetic radiation called heat radiation. It requires no medium for heat transfer. Earth receives energy from sun by means of radiation. Thermal radiation. The electromagnetic radiation emitted by a body by virtue of its temperature is called thermal radiation. When this thermal radiation falls on other bodies, it is partly reflected and partly absorbed. The amount of heat that a body can absorb by radiation depends on the color of the body. Black bodies absorbs and emit radiant energy better than bodies of lighter colors. We wear white or a light colored clothes in a summer so that they absorb the least heat from the sun. During winter, we use dark colored clothes which absorb heat from the sun and keep our body warm. The bottom of the utensil for cooking food are blackened so that they absorb maximum heat from the fire and give it to the vegetable to be cooked. Newton's law of cooling. The rate of the rate of loss of heat is directly proportional to difference of the temperature. The difference of the temperature between the bodies and its surrounding. The loss of heat by radiation depends upon the nature of the surface of the body and the area of exposed surface. Minus dq divided by dt is equal to k into delta t, where k is a positive constant depend upon the area and nature of the surface body. Curve showing cooling of heat water with time. Temperature and the relation between temperature and time.